understand what is the right way of solving the questions of pH. This is very important, okay? So just pay attention. Let's start with the first question. See, the very first thing that you need to do is when you need to know what is the meaning of 10 raised to power minus 3 molar. What is the meaning of this? It means that we have added 10 raised to power minus 3 moles in 1 liter of water, as we are taking water as the solvent. Now interestingly, this 10 raised to power minus 3 molar HCl, you are getting H plus from here as well as you are getting H plus from water. As we have already discussed that in case of neutral solution or in case of water, the H plus ion concentration is 10 raised to power minus 7. So there are two sources of H plus over here, okay. So the first step over here is to find out what is the H plus total. So the H plus total is 10 raised to power minus 3, which comes from HCl, plus 10 raised to power minus 7, which comes from water. Okay. Now here you have to keep one thing in your mind, and what is that? If H plus concentration from acid is equal to or lesser than, is equal to or lesser than 10 raised to power minus 7, we have to consider the H plus concentration from water. Okay, now this is very important. Please keep this thing in your mind. Okay, so here if the H plus from the acid is lesser than or equal to 10 raised to power minus 7, we have to consider the H plus from water. In this case, it is not lesser than, it is not equal to 10 raised to power minus 7. So here in this case, we can neglect this 10 raised to power minus 7. So I am specifically writing this particular part, that neglecting the H plus concentration from water. I have to neglect this value. So the H plus concentration total will be 10 raised to power minus 3. Therefore pH is equal to, and this is the answer. Okay. Same way when I am solving the second question, over here it is 10 raised to power minus 3 molar NaOH, and as you can see, OH minus ion total will come out to be 10 raised to power minus 3 plus 10 raised to power minus 7. So we are neglecting it. Why we are neglecting? Because the value is greater than 10 raised to power minus 7. So we are neglecting this value. Okay. Therefore, so pOH will come out to be 3. Now pH is 14 minus pOH. So it will be 14 minus 3, answer is 11. Okay. At this point, any doubts to anybody? Any doubts to anybody? Okay, great. Let's go to the next part. Third part. 10 raised to power minus 8 molar HCl. 10 raised to power minus 8 molar HCl. Now, as you can see in this case, the H plus total will be 10 raised to power minus 8 plus 10 raised to power minus 7. Here I cannot neglect this part. This is from HCl and this is from water. Now, you know what normally people do is, the first mistake that the students do is take the pH to be 8, which is not possible because HCl is an acid. The second mistake that they commit is, they simply add it up. They say, sir, we will take 10 raised to power minus 7 out. So this will be 10 raised to power minus 1 plus 1, which is 1.1 into 10 raised to power minus 7. And this is the H plus total concentration. And then they calculate the pH. But my dear friends, let me tell you, this part is wrong. You cannot do it like this. You'll ask me, sir, why is it so? I'll give you the reason for that. The reason is, see, H2O is dissociating to form H plus plus OH minus. Try to get my point. So this is H2. H plus and OH minus ion concentration over here. 10 raised to power minus 7, 10 raised to power minus 7. Now what I have done is, now I have added HCl into it. I have added HCl into it, right? So when I have added HCl into it, how much HCl I am adding? 10 raised to power minus 3 molar. So now this will be the total concentration of H plus ion. Agreed? Oh, sorry, I have done 10 raised to power minus 8. Yeah. This is the total concentration of H plus ion. But as per the Lee-Chatelier principle, if you remember, if you increase the concentration of the product, the reaction moves in the backward direction. So when you have added this concentration, the reaction starts moving in backward direction. It starts moving in backward direction. Okay. So let us say now X amount is moving in the backward direction. So this will also become 10 raised to power minus 7 minus X. Or I may write it like this. Minus X. Right? So let us see what is the H plus concentration now. H plus concentration now is equal to 10 raised to power minus 7 plus 10 raised to power minus 8 minus X. Let me write it like this, 10 raised to power minus 7 minus X plus 10 raised to power minus 8. What is the OH minus ion concentration? 10 raised to power minus 7 minus X. Right? So let us suppose, let Y is equal to 10 raised to power minus 7 minus X. Okay. Therefore, H plus concentration comes out to be Y plus 10 raised to power minus 8, and OH minus ion concentration comes out to be Y. Agreed? Because I am taking this value to be Y. Now, also we know that H plus concentration into OH minus ion concentration is equal to 10 raised to power minus 14. So you are saying that Y plus 10 raised to power minus 8 into Y is equal to 10 raised to power minus 14. So you are going to get Y square plus 10 raised to power minus 8Y minus 10 raised to power minus 14 is equal to 0. Okay. So what do you get over here? You get a quadratic equation over here. Okay. So Y is equal to minus 10 raised to power minus 8 plus minus under root of minus whole square minus 4 into 1 into 10 raised to power minus 14 by 2. Right? So if I solve it out, it will be minus 10 raised to power minus 8 plus minus. This is 10 raised to power minus 16. And this is minus 10 raised to power minus 14. So plus 4 into 10 raised to power minus 14 by 2. Okay, fine. So this value comes out to be minus 10 raised to power minus 8. See, but if it is another minus sign, this will not work out because the whole value will be coming into the minus. So I am taking the plus sign over here. Plus. Now this is 10 raised to power 16 plus 10 raised to power 14. So what if I take 10 raised to power 14 out? It will be 10 raised to power minus 2 plus 4. Minus 14 by 2. Okay. So if I solve it out, I will be getting minus 10 raised to power minus 8 plus 10 raised to power minus 7. Okay. Into under root of 4 plus 10 raised to power minus 2, that is 4.01. Okay. Divided by 2. Fine. So now this can be simply written as into 2 divided by 2. Okay. So this can be written as minus 10 raised to power minus 8 by 2 plus 10 raised to power minus 7, or I can write this thing as 10 raised to power minus 7 minus 0.5 into 10 raised to power minus 8, which is equal to 10 raised to power minus 7 minus 5, or I can rather say 0.05 into 10 raised to power minus 7. So this comes out to be, this is 0.95 into 10 raised to power minus 7. Okay. Now this is the H plus ion. Now this is equal to what? This is equal to Y. Okay. Now what is Y? 10 raised to power minus 7 minus x is equal to 0.95 into 10 raised to power minus 7. Okay. So this comes out to be 10 raised to power minus 7 minus 0.95 into 10 raised to power minus 7 is equal to x, which is 1.05 into 10 raised to power minus 7. This is the value. So you will say, sir, what is it that you got after so much of a calculation? See, what I got over here is that I cannot take it like this, 1.1, because the value is coming out to be 1.05. Because the value is coming out to be 1.05. Now this is only x, or rather, because I have to find out this is this plus this. So wait a second. No need for doing all this part. Let's not do this. Because what is the H plus ion concentration? The H plus ion concentration is Y plus 10 raised to power minus 8. So 0.95 into 10 raised to power minus 7 plus 10 raised to power minus 8. So now if I take 10 raised to power minus 7 common, I will be getting 0.95 plus 0.1. Okay? Fine? Tell me, is this point clear to all you guys? See, if I take the this is 1.1 into 10 raised to power minus 7. If I take the log of this, if I take the log of this value, I get 6.958. Okay. So if we would have used this value, the pH would have been 6.958. Okay. But Now the value is coming out to be 6.978. Now over here the pH is coming out to be 6.978. Previously it was coming out to be 6.958. Now a few of you would be asking me, sir, how much is the difference? It is 7, it is 5. Why for a small change you are doing so much of a hard work? How much is the difference over here, my dear friends? 0.02, right? The difference is of a value of 0.02, right? The human blood is having a pH from 7 to 7.3 normally. And if the pH of human blood varies by this value, 0.02, happy birthday to you, happy birthday to you. You got my point? The person will die immediately if only this amount of pH changes. So this 0.02 which we have got by this calculation is worthful calculation. It is not worthless. You need to know how you got this particular value. So why the answer should be 6.978 and why it should not be 6.958. Am I clear with this? Okay. So same way you can solve it for the basic solution, that is 10 raised to power minus 8 molar NaOH. So over here also the OH minus ion concentration will come out to be, as it is coming out to be, 1.05 into 10 raised to power minus 7. So POH will come out to be 6.98. I am taking correct up to second place of decimal. Therefore pH will be equal to 7.02. Okay, understood? Okay, now let's go to the fifth question. I am saying 10 raised to power 2 molar HCl. See, let's try to understand what is the meaning of this. 10 raised to power 2 molar means 100 moles of HCl in 1 liter. 100 moles. 1 mole is 36.5 grams. So what do we mean to say over here? We mean to say 3650 gram of HCl in 1 liter of water. In 1 liter of water. 3650 gram of HCl in 1 liter of water. Do you think this is practically possible? Can you mix 3650 grams, 3.65 kg of HCl in 1 liter of water? Possible? No, it's not possible. So for all such solutions which are having such higher concentration, we will assume the H plus to be 1 molar. That is, we will assume the pH to be equal to 0. Okay, question, the 2 more to go. The sixth question is 10 raised to power minus 2 molar H2SO4. Now over here you guys have to remember one very important thing. Let's see, though we are using the term molarity over here, but my dear friends, we should not be using molarity. We have to use normality always for concentration. Now you would ask me, sir, in the first 5 questions you have not used. Why? Because in all those cases molarity and normality was same. Dono barabar thi bhai. So we didn't have to change it. But over here there is a difference. See, normality is equal to molarity multiplied by n factor. For HCl the n factor is 1. For NaOH the n factor is 1. So molarity and normality are same. But in the case of H2SO4 it is 10 raised to power minus 2. N factor over here is 2 because the basicity of H2SO4 is 2. So the H plus ion concentration will be 2 into 10 raised to power minus 2. So pH will be equal to negative log of 2 into 10 raised to power minus 2. So which is minus log of 2 plus log of 10 raised to power minus 2. Log of 2 is 0.3, log of 10 raised to power minus 2 is minus 2. So the answer is plus 1.7. This is the answer. Let's talk about 7th part. See, here we are talking about a weak acid. Normally in any weak acid this Ka, and in a weak base the Kb value will be given to you. So you can easily identify. Okay. And if it is given for all, please remember, if the value of Ka is lesser than 10 raised to power minus 3. If the value of Ka is lesser than 10 raised to power minus 3, then it means it is a weak acid. If the value of Kb is lesser than 10 raised to power minus 3, it means it is a weak base. Okay. So now, this is a weak acid. So what I'll do is, I'll first give you a generalized way of calculating the pH so that you take minimum time to get the answer. Ha plus aqueous is giving you H plus aqueous, A minus aqueous. Agreed? Okay. If I take initially the concentration to be C at equilibrium C minus C alpha, C alpha, C alpha. Agreed? Now see, my dear friends, since we are talking about dilute solutions, for dilute solution, the Ka is equal to C alpha square. Agreed? Now what I'll do is multiply both sides by C. So this becomes CkA is equal to C square alpha square, or C alpha is equal to under root of CkA. Now my dear friends, what is C alpha? C alpha is nothing but the H plus ion concentration. Okay, that is H plus ion concentration is equal to under root of Ck. So from here I can write pH is equal to negative log of CkA raised to power half. So I can write this thing as minus half log of C into K. Now this becomes a straightforward formula for you to solve the question. Now what I have to do over here is, I have to put these values over here and get the answer. See, minus half log. What is C? 0.1. What is Ka? 10 raised to power minus 5. So this is minus half log 10 raised to power minus 6, which is minus half into minus 6, which is equal to 3. So you see, you can solve this question verbally, no need to use the pen. No need to use the pen. Verbally you can solve this question. Got the point? Okay. Similarly, if I have to do it for a weak base, so there, see, this is BOH from B plus aqueous plus OH minus aqueous. Okay. Same way C minus C alpha, C alpha, C alpha. Okay. Same way over here, Kb is equal to C alpha square, or C alpha is equal to under root of Kb into C, or OH minus ion concentration is equal to under root of Kb into C, or simply saying POH is equal to minus half log of Kb into C. And you know this part, that pH plus POH is equal to 14. So the pH is equal to 14 plus half log Kb into C. Okay, so in this case pH is equal to 14 plus half log of 10 raised to power minus 5 into 0.1. So this value, this comes out to be minus, plus only, no? So this will be 14 plus half into minus 6. So the answer comes out to be 11. Okay, and this is the answer.